Flywheel provides researchers with a best-in-class, end-to-end AI model development suite for medical imaging. If users have access to their own data, it can be imported into the system in a multitude of ways, including case-by-case via our web uploader, in bulk from the cloud, or automatically pulled off of the imaging instrument. As data flows into the system, users can leverage Flywheel's Gear framework to build automated curation pipelines. This streamlines metadata extraction, image classification, and initial quality control. With your data through the automated curation pipeline, Flywheel users can then orchestrate human-in-the-loop reviews of the images using our Reader Task functionality. Those images that meet the inclusion criteria for your model development can then be assigned to imaging experts for interpretation and annotation, generating the ground truth for your model to learn from. Easily compare multiple experts' interpretations simultaneously in the viewer for rapid and concise adjudication. Flywheel orchestrates the compute setup, data staging, and authentication to streamline your ML development. Users can leverage existing frameworks to optimize training or define their own custom optimizers, schedulers, and loss functions. With your parameters defined, model training can be initiated. In this example, we used a typical PyTorch training process. The training loop was ran over 300 epochs, and the dice scores plotted for each. Note the improvement in model performance over time. With your model sufficiently trained, users can then validate its performance on a new dataset, reviewing the output directly in the ML environment. The notebook, model code, and outputs can then be easily saved back to your Flywheel project for reuse and sharing. To learn more about how Flywheel can help unlock AI advancements in oncology, contact us today.